Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account.
Hi everyone. Today we have with us Karyns Jarvis, who is a senior research engineer at Swinburne University of Technology in Melbourne, Australia. Hi Karyn, how are you doing?
I'm well, thanks. How are you?
I'm good. Ready to take a deeper dive into your science. So let's start by understanding your career so far. So tell us about your scientific journey so far as a research engineer, senior research engineer in Australia.
It's been really interesting. So I was never particularly interested in science as a young kid. I was overall quite academically gifted, so I did fairly well at a lot of subjects, and I never really knew what I wanted to do. I got to the end of high school and I thought, do I want to do something with maths? Do I want to do something with geography? Subjects I really liked, but I couldn't really see how I could apply those sort of things in a career. And I thought, I like science, I like chemistry, why not? So I didn't really think about it much more than that. And I actually found a degree at the University of South Australia, and that was a 100% chemistry degree. So it wasn't like a science degree where I had to do majors and minors. And I thought, that sounds interesting. So I enrolled in that. And I actually really loved that degree because it meant that in second and third year, I did 4 chemistry subjects each semester. And it meant I got to spend every afternoon in the lab, which I really enjoyed. And then I kind of didn't really think about it any more than that. I got to the end of my 3-year degree and I thought, well, I don't know what I want to do. So maybe I'll go and do a 1-year honours program, which is kind of the way that we do it in Australia. You do a 3 or 4 year degree with or without honours. So I did a 1-year honours project where I did part coursework and then part research, which was my first real opportunity to do my own research project, which I really enjoyed. And then again, thought, I kind of like this. So I stayed at the same institution, University of South Australia, and did a PhD. And that was looking at modifying surfaces for drug delivery. And again, I really enjoyed that, really enjoyed the independency. But I didn't, again, have a strong feeling about what I wanted to do afterwards. I didn't necessarily want to have an academic career, but I also didn't necessarily want to get an industry job. And industry jobs aren't as common in Australia as they are in other areas, because I guess a lot of R&D companies don't do R&D in Australia. So I thought, maybe I'll do a postdoc. A postdoc seems like a good idea. And when I graduated in 2010, it was the global financial crisis. Internationally, jobs weren't as easy to come by as perhaps I would have hoped. I had a couple of interviews for overseas postdocs, didn't get one. And then an opportunity came up at the University of South Australia. So I stayed on and did a 3-year postdoc, which initially I wasn't super keen on. I just thought it's an opportunity. But I was even saying to someone today, if I hadn't have taken that postdoc, I wouldn't be doing what I do today. It was my first foray into plasma polymerization. It was a really well-funded project, so it means I got to travel. I supervised a PhD student. I got to write papers. My supervisor let me work quite independently, so I learned a lot about how to do research and how to manage a project and things like that. So that was 3 years. That came to an end and I didn't have another job to go to. But luckily another one came up in Sydney. So I was working in Adelaide, which is where I'm originally from. So from Adelaide to Sydney, it's about 2,000 kilometres away. So I got a job doing a second postdoc at the Australian Nuclear Science and Technology Organisation. I've got too many Australian nationals in my head, which is a federally funded government lab which has Australia's one and only nuclear reactor, which is a research reactor. So I moved to Sydney for 2 years, and there I was working on a project on creating thin films for protecting organic solar cells. So again, this theme of surface modification, thin film deposition, but going from drug delivery to water treatment, which was my first postdoc, which I didn't say, and then solar cells. And I was in Sydney for 2 years. I really enjoyed that. But when that was about coming to an end, my partner, who I met during my PhD, he was in Italy doing a postdoc. So we were separated for 4 years. And his postdoc finished up and he got a job in Melbourne. So I thought, oh, well, even if I don't have another job to go to, I'll just move to Melbourne and see what happens. But I knew a professor from Melbourne who I'd visited a couple of years before and had met at a conference and things like that, and had talked to her. She worked in plasma polymerization, and she said, oh, I've got somebody leaving. If he leaves, you'd be really good for that job. And then 6 months later, Australia sites is quite small. So I heard from a mutual friend that he had announced that he was leaving. So I sent her an email and she phoned me back and she says, oh, I've got this job for you. It's only a short-term contract, so you can have it. And that was 6 years ago, and I'm still at Swinburne University of Technology looking into plasma polymerization and managing this open access user facility that we have.
That sounds really, really cool. Wow. From not being, well, yeah, I'm academically inclined, but well, not really. I'm just gifted to being a research engineer, senior research engineer now at Swinburne. Swinburne in Australia, in Melbourne. It's quite a lot of different labs that you've worked at, and that sounds really, really cool. And also the work that you define, we'll talk more about it, of course, later on, but this sounds really amazing. I mean, traveling scientist within Australia, let's put it that way, lab hopping.
Which is not actually that uncommon. I mean, I guess, people probably do it in Europe or America, but yeah, it's kind of the same in Australia. Like, there's people I know now who, I've lived in different cities at the same time with, who people I used to work with at one institution and now somewhere else, and I still work with them. So yeah, it kind of, sometimes when you meet somebody, you're like, oh, where are you now? Because it's just the way it happens, especially I think in the early part of your career. If you've only got short-term postdocs, you go where the jobs are, basically.
True, absolutely, and I hope now you're very, very happy with the job.
I am. I do enjoy it.
It sounds like that. So that brings me to the next question, which is, I mean, you already spoke about your current research in the short podcast, but where does it fit in this big picture of materials or nanoscience? Because it's quite a broad field, right? Material science. So where does it fit in?
Yeah, so mine really fits in with the sort of nanoscience area. So I've talked a little bit about these thin films that I deposited, and it's really that kind of interface. It is actually the interface of nanoscience and materials, because we're putting a nanometer thin coating on a material. So I said in the short podcast that surfaces are really important and they control how a material interacts with the environment around it. So I used a few examples, and one of the examples I like to use is, say, a hip implant. So, you might take a piece of steel, which we all know what a hip implant looks like, and to put it in the body for its structural properties. So, the person, their leg needs to work and to move. But the material properties that hip implant has for strength aren't necessarily properties that serve the surface particularly well. So if you just say put a piece of metal in the body, you might have a couple of different responses. Your body might reject it because your cells in your body aren't actually interacting with it, or you might actually get what they call a foreign body response. So the cells in your body might attack that, and then your body will reject it. So by putting different coatings on these types of materials, you can really manipulate the way that proteins or anything in sort of solution around that object interact with it. So you might want to attract proteins or attract certain types of cells so that material integrates into the body. Or you might want to put coatings on it that repel bacteria so it doesn't get infected. Or there's a lot of work with like what they call drug eluting materials. So you might actually absorb antibiotics onto the surface so that then over time they're released so that, this foreign material in your body doesn't recognize it as foreign.
Okay. Wow, That sounds really cool. And it sounds to me that you have been, not just your current research, but also in the past, also, you have been involved in a lot of interesting research projects.
Yep.
So the next question is a difficult one. I know that before even asking it. If you have to pick one research project that you're most proud of, or the most fun or quirky one, could you pick one and explain it to us in simple words in the section we call In Other Words?
This was a hard question, and I did think about it. I guess everybody probably says that. I'm proud of all of the work that I've done, but
Right.
I think my first postdoc was because, as I said before, it wasn't a project that I was super keen on to start with, but I really came to love it. I got the opportunity to supervise a PhD student, and together we had a lot of publications. We spoke at a lot of conferences. It was a really productive time.
Mhm.
And I feel like the research we did really added to the body of work in that area. So I briefly mentioned that we were working on water treatment. So
Mhm.
what we were doing is we were putting these plasma polymer thin coatings onto sand particles, just everyday sand particles. And this is an area called decentralized water treatment. So, a lot of us in developed countries turn on the tap and get water.
Mhm.
And that's all well and good until there's a flood like they've had in places in Europe, and then the whole water system is destroyed, and even people, living in houses don't have clean water. So the idea is that these sand particles can be used just to filter water. You might have it in glass, and you can use these sand particles to filter the water. So by putting these chemistries on the surface, we could attract different water contaminants out of it. And then I was working on some of that, and my PhD student, he developed a nice hydrophobic coating. So that's a water hating coating. So if you think of something like a droplet of water and a droplet of oil, they don't mix because one is water loving and one is water hating. So by putting a water hating coating on these particles, we could actually extract oil and petrol out of water, which is a huge issue if you've got things like oil spills and that. So I'm proud of that project because I think we developed some really great technology which actually had some real world impact.
That sounds really cool. And is I can imagine why you picked this project as the one that's one of the ones that is you're most proud of. And is this technology being used? Did it transfer from the lab bench to the market shelf?
We didn't actually commercialize it, and I'm just trying to. I was thinking about that. I'm like, why did we not? And I don't know whether it was just the way the technology. It kind of wasn't. It was unique, but it wasn't super novel. Like we weren't the only ones doing it. So I guess there's a suite of technologies. I feel like we progressed the technology, but we kind of didn't. It wasn't patentable, and I think that's the thing with a lot of commercial work is that it has to be a process that is patentable, because otherwise people aren't going to pay to make a product that someone else down the road can just do just as easily. So it was kind of like assumed knowledge, but I still think it was useful. And if people can use it in a non-business way just to improve water quality, I think that's a good outcome too.
Absolutely. Yeah, absolutely. This is definitely cool. And it sounds very simple once when you say it, it's like, yeah, duh, obviously. But
I think that was the case. I think that's why, when we talk to, business people, they're like, well, yeah, duh, like everybody knows that. So yeah, why we can't really make a product out of that. But
yeah, okay. Okay. Well, but I still think it's really, really cool. This project is very, very cool. And I hope you talk about this project, the details of the project when you're curating the account, so that
I will.
maybe
Yeah,
then you will get some interest.
there's some we had some cool videos. We actually, on the very last day I was on that job, we had a TV show come in, like a children's science TV show. They came in and did a segment for that, and we've got some really cool videos of it, like pulling oil out of water. So it was really good.
You still have those videos, right?
Yeah, I'll have to find them. Yeah.
Okay, awesome, awesome. Would love to see those videos. So, Karyn, it sounds to me that you really enjoy the research aspect of being a scientist or being an engineer. But other than there are different aspects to you as an engineer or a scientist, right? So, what else do you like about being a scientist other than research?
For me, it's definitely the people, and the word that I use, especially now with the job that I do, is facilitate. So while I do my own research, the thing that I enjoy the most is helping other people with their research, facilitating their research. And I think there's all types of personalities in science, and there's some scientists that really love sitting in a basement lab on their own, not being bothered by anybody. But that's not me. I love talking to people. I love talking to people about their research. I like meeting people and helping them out and things like that. So it's not something I think a lot of people generally think about when they think about being a scientist. They've got this picture of scientist, and a sociable, outgoing person who loves to talk is perhaps not what you picture as a scientist, but it's definitely the bonus of my job that I like the most, is the variety of people I get to work with.
Yeah, that sounds really nice. That is, it's also relatable for me. So I love that part as well when I was an active researcher. So, Karyn, you have so far gained a lot of experience in your scientific career. So, what advice would you give to the researchers starting out today, like students who are starting out today, or if you were to go back in time and talk to your younger self, what advice would you give?
The one piece of advice I always give is take opportunities to do summer projects and internships and things like that, because that's how I found out I wanted to do research. So between, I think, second and third year, I did a project in a summer job in a cement factory quality control lab, which was interesting. And I learned a lot about how they look at cement, but it was quality control. It was very repetitive, very sample, these are your list of samples that you've got to look at today. And then once you've done that, and I found that quite boring. Like I just didn't. And I always say the thing that I like about what I do is the variety. That most of my days are different, whether I'm in the lab, whether I'm writing, things like that. And for me, that sort of job was just too repetitive. So then the next summer, I did a summer research project in water quality. So that might have been indicative of how I ended up working in water quality. But yeah, I just enjoyed that much more. I enjoyed the having a problem to answer and having different things to do. It wasn't just the same thing day after day after day. And that's what kind of led me to thinking, okay, this is the type of job that I want. Okay, if I want to do a research job, I probably need a PhD. So yeah, number one piece of advice is do summer projects, do interns, work in different labs, all of those sort of things. So you can not just carve out the type of job that you want, whether it's research or quality control or R&D or all of those sort of things. But yeah, also the type of job that you want. Do you want to work in a lab? Do you want to work at a university? Do you want to work at I worked at the federal lab for 2 years. So just, take the opportunities you can and try not to get too locked into one thing too early, and who knows where you'll end up.
That's a very, very fine piece of advice. Diversify your lab experience and take opportunities.
Yeah.
Even if it sounds boring, I'm pretty sure you will learn something, some or the other thing on that.
Even if it's I spent 6 weeks working in the cement factory, and it was at the end, they asked me to stay on for even longer, and I was like, no, I can't do this. But it taught me a lot, and now 15 years later, I still talk about that experience. So
absolutely, and the worst that would happen is that you will know what you don't want to do, right? Because this sounds very familiar to my first internship. It was a winter internship for a month or so in a steel factory, like an iron and steel factory where they had these huge furnaces, and I was in the quality assurance department, quality assurance of steel and stuff what is this? But after that, I had fun for that 1 month, and after that 1 month, I was like, okay, I'm pretty sure I definitely don't want to do this.
Yeah.
Yeah, so you learn things, definitely. So take opportunity. That's a very, very fine piece of advice. Awesome. So, Karyn, I hope your research experience has been wonderful so far. It sounds like it has been wonderful, and I hope it will be wonderful in the future as well. However, if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here, okay?
That's a pity.
Sorry.
Yeah. So this was again really interesting to think about. So I think what probably a lot of researchers say is stability of funding. That I think it seems like nice to move around, and it is, but it is really hard, especially if I feel for people who want to stay with their families, who have children, all of those sort of things, that sometimes you do just have to move around where the jobs go. So I think having the option of stable funding, I think is definitely benefit. And we lose a lot of people, a lot of well-educated, well-trained people, just because there's no stability of funding. So that's definitely, I think, the number one for me. The second one is work-life perception. So I've been saying this for many, many years, is that I love being a scientist. I don't love it 80 hours a week. And I feel like a lot of scientists these days feel like they need to work really long hours. And it's kind of this continually moving bar, is that while there are scientists who work the long hours, they're much more productive, they get more papers, they get more grants, they supervise more students. And then other people see that and they think, okay, that's what I need to do to get ahead. And then the bar lifts for, the expectations. And, there's lots of, older scientists who say, I would never get a postdoc, I would never get a grant, I would never get a job now, because the expectation of the output is just so much higher than what it used to be. So I don't know how to solve that, but it's just something I've noticed, is that people just feel like they have to work really long hours to be a successful scientist. And I would really love to see that change. And the third thing I said is the ordering process at my university. I just ordered a chemical and I hate it. And I just spent so long, and the administrative things that sometimes we have to go through to be able to do our job, it's just like, there's got to be an easier way of doing this. So yeah, I would love just to have some sort of like magical fairy who just gets me the things I need, and I don't have to fill out a form or get finance approval or get the head of school to sign off on it or things like that.
All three very fine wishes. Job stability, work-life perception. That's a very, very important word. I think we often talk about work-life balance, but the perception is that exactly what you mentioned, that people think, that the scientists today think that they have to work 80 hours, and then it's like this chicken and egg. Like, who stops it? You have to break that cycle somewhere. So perception needs to change. You're absolutely right. And the ordering process. Yeah, I hope it comes to the point where you can just write an email or just think about, okay, this is what I want to order, and it just appears in 1 week or 2 weeks time, however long the delivery is. All very fine wishes. I hope they all come true. I really, really hope they do come true. And this has been wonderful, Karyns, talking to you, learning about your science. But before we let you go, we have one last question for you, and that is the interesting times that we are living in. The year 2020 is when it all started, at least for Europe. And most of the world, and also spilled over in 2021. So what are your learnings from this very unprecedented times that we are living in?
So I learned a few things. I learned that lockdowns are really good for paper writing. So like a lot of academics, I had a bit of a paper backlog. So we needed permission to go on campus during Melbourne's lockdowns in 2020, which I decided not to. So I just decided to stay at home and prioritize paper writing. And I feel like a lot of my collaborators did as well, because I've got more 2021 publications than any other year in the past. So that's been good. I feel like I know how I work better now. Like, I'm very much a 9 to 5 kind of person, and I've kept that up in working from home. Whereas I've got friends who, worked less hours but over more days, so they could feel free in the afternoons to go and do things. So I feel like a lot of, me included, have learnt how we worked, and that kind of feeds into that working from home. So I guess a lot of people, I probably won't go back to being in the office 5 days a week. That I'll go in 3 days a week to do my lab work, and then probably spend a couple of days a week at home doing paperwork and paper writing and things like that. I feel like it's a good balance, especially when you're commuting and things like that. So I learned about how I work in 20.
Okay. Wow. Thank you very much for sharing those learnings. And paper writing, lockdowns are very good for paper writing. That's a very positive outcome of the lockdowns. One of the positive outcomes. Let me put it that way. So thank you very much, Karyn. This has been wonderful. Looking forward to having you on Real Scientist Nano.
Excellent. Thank you very much.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.